Japan is hollowing out a mountain to make a huge water bottle. A $500,000 tank, which would be 80 meters high and nearly 70 meters wide. That could easily fit the Leaning Tower of Pisa. However, there is no way that you can spot this giant structure. But why is that? Well, because it's 681 meters below the mountain peak. And once this beast is completed, it will solve our universe's biggest riddle. Sounds too crazy to be true. What is this thing? And what puzzle are the Japanese trying to solve? Today, we'll find that out together. Let's start with something simple, as you'll first need to refresh your understanding of science. But don't worry, I'm here to help you with that. Did you remember seeing your teachers draw on the chalkboard these subatomic particles that our universe is made of? Yes, most of you might have heard about quarks, bosons, and the tiniest of all, the neutrinos. Neutrinos are the real bad boys, but they act a bit weird. They're even smaller than atoms, making them extremely difficult to spot. For instance, a neutrino could pass through a packed football stadium, weaving between every single person in the stands, and still have more empty space around it than the entire stadium itself. But what's cool about them is that scientists believe if we could figure out neutrinos, we could completely change how we see the universe. And that's why a team of daring Japanese scientists decided to chase the impossible. So it began in 2020, when they started hollowing out this mountain known as Hyper-Kamiokande. You might be wondering why the scientists chose this place exactly. Why a place this remote in the mountains? Well, you see, one way of detecting neutrinos is by smashing larger particles together at high speeds and recording the reaction. But that's already happening in Switzerland's Large Hadron Collider. Another way to observe them is just by listening, and for that you need a super quiet and remote place. See where we're going with this? That's how the idea came of building this Super-Kamiokande neutrino observatory, right here, deep below the mountains of Hyper-Kamiokande. But it's not just your ordinary observatory. It's home to the world's largest water tank, 260,000 tons. That's enough to fill about 33 Olympic-sized swimming pools. The water it contains has to be cleaner than you can possibly imagine. So pure that Super-K constantly has to filter and re-purify it, and even blasts it with UV light to kill off any bacteria. However, if the thing was all about neutrinos, why is there so much water here? Why is this water cave being built which is 4.5 times larger than the world's largest aquarium at SeaWorld Abu Dhabi? Let me explain. To understand the catch, you need to know a bit of history about the project. Believe it or not, this isn't the first time something like this has been done. This will actually be the third Kamiokande built in this area. You see, this part of Japan has a history of zinc mining. It was the skill and knowledge of a local mining company that helped build the first Kamiokande back in 1983, short for Kamioka Nucleon Decay Experiment. That success led to the creation of the Super-Kamiokande in 1996, and now we have the Hyper-Kamiokande, currently under construction. You're still probably curious to know about the huge water tank and how it would change our lives and the universe, which sounds like a deepfake, right? Trust me, we'll reveal that one shortly. But first, let me take you through the fascinating process of building this colossal megastructure inside of a mountain. The plans for the Hyper-Kamiokande go way back to 1999. After more than 20 years of planning, they finally started work in May 2021. Using drilling and blasting techniques, they managed to dig out a 2-kilometer access tunnel in just 9 months. They then reinforced it with concrete for a smoother surface. This tunnel leads right into the heart of what will become the observatory's roof. Sitting 681 meters below the mountain peak, they had to create a dome structure to support the weight of all that rock. That was finished in October 2023, and now they're blasting through another 71 meters of rock to create the cavern where the observatory will sit. It's tough work for the construction teams, but it's what makes this spot ideal for spotting neutrinos. How cool is that? The density of the rock here is equivalent to being 1.7 kilometers below the ocean's surface. That's perfect for neutrinos, which can zip through planets without a hitch. Plus, it shields the experiment from cosmic rays and background radiation that could mess things up. The drilling should finish by 2025, but there's still a long road ahead before they can detect even a single subatomic particle. And now, with all the history and some important details done, we're ready for the main course. Before we answer it, we would really appreciate your feedback down below in the comments. You see, this water tank is here for a big reason. This massive volume allows for a much larger target for neutrinos to interact with. And this image shows the crater of the tank. Look how massive it is. So, scientists would force the neutrinos to pass through this tank. As neutrinos travel through the tank, sometimes they bump into electrons, producing a faint light called Cherenkov radiation. That's exactly what this entire setup is designed to detect. Small flashes of light within the enormous water-filled chamber. Just take a look at these detectors. There would be not one, not two, nor three, but almost 40,000 photodetectors to detect the flashes of light. Once done, they would act as one big camera. To put that in perspective, imagine if every iPhone user on a crowded stadium floor switched on their phone's most advanced night vision mode. That's almost like a network of 40,000 photodetectors. But of course, this is a massive undertaking and will require time. If you're eager for a preview, we suggest taking a look at its smaller counterpart, the Super-Kamiokande, which is less than half the size. And here, you can see the atom detectors lining the walls. But you know, the new sensors for Hyper-Kamiokande are almost twice as sensitive and are designed to handle the massive weight of 260,000 tons of water. The construction is set to finish entirely in 2026, and by 2027, Hyper-Kamiokande will begin its work of detecting neutrinos and conducting experiments. Nevertheless, no matter how fascinating this is, there is one more little thing to uncover. So as promised, let's get into the riddle of neutrinos. Why would we even want to catch them? If there's a supernova, a star that collapses into itself and turns into a black hole, if that happens in our galaxy, something like Super-K is one of the very few objects that can see the neutrinos from it, because before a star starts to collapse, it shoots out neutrinos. So, it seems like a perfect warning system for us, right? Moreover, the experiment conducted on the other side of the country, known as T2K experiment, which was about firing a neutrino beam 295 kilometers through the Earth, and then picked up by the Super-K, showed that the way the neutrinos change as they pass through matter may tell us more about the origins of the universe, and/or understand the relationship between matter and antimatter. Also, these little neutrinos are crucial for our future, kind of like how we imagine our future AI to be. Because neutrinos can travel long distances without much stopping, we might use them for super secure communication across far distances. They could also help doctors by improving X-rays and making them more powerful. But don't forget, understanding atoms and particles like neutrinos has already helped in big ways in medicine, like with AIDS treatment and lots of other important medicines. So what do you think of Japan's latest megaproject? Let us know in the comments. Thank you for watching, and until the next one.